Machine learning technology powers many aspects of modern society. From web searches to content filtering on social networks to recommendations on e-commerce websites, and it is increasingly present in consumer products such as cameras and smartphones. Machine learning systems are used to identify objects in images, transcribe speech into text, match news items, posts or products with users' interests, and select relevant results of search. Increasingly, these applications make use of a class of techniques called deep learning. Deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and function of the brain called artificial neural networks. Conventional machine learning techniques were limited in their ability to process natural data in their raw form. For decades, constructing a pattern recognition or machine learning system required careful engineering and considerable domain expertise to design a feature extractor that transformed the raw data, such as the pixel values of an image, into a suitable internal representation or feature vector from which the learning subsystem, often a classifier, could detect or classify patterns in the input. For most flavors of the old generations of learning algorithms, performance will plateau. Deep learning is the first class of algorithms that is scalable. Performance just keeps getting better as you feed them more data. Deep learning methods are representation learning methods with multiple levels of representation, obtained by composing simple but nonlinear modules that each transform the representation at one level, starting with the raw input, into a representation at a higher, slightly more abstract level. With the composition of enough such transformations, very complex functions can be learned. For classification tasks, higher layers of representation amplify aspects of the input that are important for discrimination and suppress irrelevant variations. An image, for example, comes in the form of an array of pixel values, and the learned features in the first layer of representation typically represent the presence or absence of edges at particular orientations and locations in the image. The second layer typically detects motifs by spotting particular arrangements of edges, regardless of small variations in the edge positions. The third layer may assemble motifs into larger combinations that correspond to parts of familiar objects, and subsequent layers would detect objects as combinations of these parts. The key aspect of deep learning is that these layers of features are not designed by human engineers. They are learned from data using a general-purpose learning procedure. The most famous types of deep learning networks are multilayer perceptron networks, convolutional neural networks, long short-term memory, recurrent neural networks.